Hello everyone. In this section, we will talk about a very interesting algorithm that we know that is used for searching in arrays. It's a very simple technique that is known as linear search. So let us talk about what is linear search. Okay, so it's a searching algorithm that is used to find the index of an element in a given array. For example, let's say you go to a restaurant and there are certain items in the menu. Let's say you have dosa, you have noodles, you have let's say rajma, okay, and maybe you have burger. So let's say you went to the restaurant for the first time and there is a large menu and you're looking for an item, let's say Coke. So what do? You start iterating through all of the menu items and you start looking at where is Coke present. So you see, okay, this is where the Coke is present inside this particular list. So what you did, you went through every item and you scanned it. Okay, does it match my requirements? If yes, I stop at that particular point. So this way of searching in an array is known as linear search, and it's a brute force technique, you can say. We are trying out all possibilities where a particular element is present. So let us look at in the context of an integer array. For example, we are given this array which contains some number of elements and we want to search for a particular key, that is 9. So what we will do, we'll go to this index and we'll check, does it match 9? No, it doesn't. We go to the next. Does it match 9? No, it doesn't. We go to the next, next, and finally we come at this place. Does this array of I matches our key 9 or not? Yes, it does match. Then what we do, we stop our search. We don't want to go any further and we say, okay, stop, and return the index of this particular element. And if this is not present, we can return some value, let's say -1, if element is not found. Okay, so what we will do, we will now write a function to do linear search, and let's see how we can write it. So I can say int linear search, we have a array and we have a integer n, okay, that denotes the size of the array. And one more thing we will get is the key, the value for which we are looking inside this particular array. So what we will do, we will iterate from int I equals to 0, I less than n, I plus plus, and here we can check, okay, check if current element matches with the key. So the current element is array of I. If this matches with the key element, then we can simply return I. Okay, we found out the element that you are looking for, and that's it. And once, if you come out of the loop, okay, out of the loop, that means you have already scanned the n elements and this return statement was not executed. So that in that case we can return -1, that this element is actually not present inside this array. Now what we can do, we can create an array of, let's say, some numbers. Let's say 10, 15, 12, 9, 6, 4, 3, 10 and 8. Okay. And n is, let's say, size of array upon size of int, and you can say the key is something that is given by the user, I don't know. So C in key, I take input that particular key and I check the index by calling this method linear search array n and key. I check if this index is not equal to -1, I print, okay, your element is present, key is present at index, and here we print the index, that is index. Otherwise we can just see out this particular key is not found. That's it. Let's build the code and let us try to run it. So this is /03 linear search, and I need to give a key, okay, let's say 9. So 9 is present at index 3, so this is what we get. So 0, 1, 2 and 3, yes, 9 is present at index 3. But if I give, let's say, the number 19, Okay, so it says 19 is not found. Now let us also talk about how much time this code will take in the worst case. Okay, so what we are doing in this code is, in the worst case, we are iterating over the entire array. So the number of operations, the number of instructions that we are going to execute is going to be proportional to the value of n. Okay, the larger is the value of n, the larger is the time taken. Okay, and it is going to be a linear function of n. So we can say this linear search has a complexity of order of n. Okay, so this is going to take order of n time. Okay, so that's all for this linear search algorithm. I hope you really understood this one, and in the next lecture we will learn about binary search.